Okay, in this problem we're told that in the year 2010 the population of a city was 75,000. In 2015, 5 years later, the population was 84,000. Let's assume the population grows exponentially and we want to estimate what will the population be in 2030. Okay, well this is the basic formula for exponential growth or decay. It's growth if k is positive, if k is negative it's decay. P is the population size at any time t. P naught or P0, that is the population size at the very beginning or the initial population size. T is our time and k is a constant. K changes with every problem. Basically k, the value of k tells us how fast or slow our situation grows, all right, or decays. So we plug everything in. So this is the beginning. 5 years later, when the time is 5, the population size is 84. So we think of this as the beginning, the time 0, okay? Then 5 years later, the population is 84,000. So P is 84,000. P naught, that's the beginning population size. At the beginning, which is 2010, the population size is 75,000. This is e to the kt. Now the time, as I said, the difference between 2010 and 2015, if this is the beginning, this is 5 years later. So the time is 5, so we put a 5 in for t. So I'm just plugging in our population is 84,000. At the beginning it's 75,000. Our time is 5. So now we divide both sides by 75,000 and we get 84,000 over 75,000 equals e to the 5k. 84,000 divided by 75,000 is 1.12. Just get out your calculator. And now this is an exponential equation that we learned how to solve in an earlier videos under the topic solving exponential and logarithmic equations. Because this has an e in it, let's take the natural log of both sides. So this becomes the natural log of 1.12. The natural log of e to the 5k is just 5k. Yeah. To solve for k, we divide by 5, and there's our value of k. All right, now what we do is we go back and we substitute that into here. All right, so now our equation is P equals the beginning population size. For this problem, the beginning population size is 75,000 times e to the kt. We just found k. K is the ln of 1.12. And then that whole thing is divided by 5. So we get e to the k, and then this has this exponent is multiplied by t. All right, so that is the formula for our population size. Now the question is, well, what is the population size going to be in 2030? Now this is an estimation because we don't know if people are going to continue to move in at exactly the same rate. Yeah, it's going to vary a little bit. So our answer is an approximation. But 2030 compared to the beginning, this is 20 years after 2010. So all we need to do is we need to plug in 20 for t. So P is 75,000 times e to the natural log of 1.12 divided by 5, and then this whole thing here is multiplied by 20. Now you could simplify. 5 goes into 24 times, all right? But point here now is we just got to get out our calculator. So now the rest of this is just making sure you can use your calculator. When you plug this into your calculator, you're going to get 118,014 if I round to the nearest whole number. So this is saying the population size will be approximately 118,000. A little bit more, but it'll be about 118,000 by the year 2030 comes around.